Hello, my name is Paul Holland. I am currently a principal consultant at Plato Testing based out of Canada, and I am going to present to you my talk on the pothole of trying to automate too much. So, welcome to my talk at Testing Stage 2023. So, let's start pretty abruptly. I'm going to tell you what automation will likely not be able to do for you. It's likely not going to increase your coverage. It's not going to decrease your risk, your costs. It's not going to save you time. It will probably not allow you to reduce headcount unless you're also increasing your risk. What automation can do for you is it can give you a decent sanity check of your product. It's not going to give you a deep check, full, ongoing, thorough, deep check. It'll give you a sanity check of your product if it's done well. And it can execute in less time than a human performing the same checks. And I would even go as far as saying it should be executed in lieu of a human doing the same checks, because humans doing checks that can be automated is not a great use of the human's time. Now, it does just execute the tests. It can't analyze the tests. It can't investigate bugs. It can't figure out why a test failed. It can execute and report on its findings, whatever it's coded to find, quicker than a human would be able to go through the tests. But it's going to be looking at fewer things. It's not going to be thinking. It's not going to be evaluating. It's not going to be aware of what it's doing. It's doing a step and checking a particular output, doing the next step, checking a particular output. So if we consider that your software is the United States of America and your software has cities or features in it, and back in 1907, so 120 some or almost 115 years ago, there weren't that many highways in your software. There weren't very many cities and places that you could go to the point that some of these states don't have any roads in them, like that one and that one. So without as much effort at the beginning, it's fairly easy to be able to follow all of the main highways through your code. But as time progresses, more roads are built, more features are built, you need more roads interconnecting them. You need more paths through the software. There are different ways that your customers can make those features interact with each other. So I might start out in a different city. If I'm going from city one to city two, I can go through a bunch of different cities on the way there. I'm going to take different roads. So there's a lot to the automation that, or testing in general, not just what's automated. So the real problem with the testing that we're doing or trying to do is that there are far more roads than we can possibly test. And this includes via automation or with a person doing it. At a glance, a high level glance, this is from Google Maps. At a high level glance, it doesn't look that complicated. There's a few roads going in and out of a few different cities. But if we zoom in on Colorado, we can see that Denver has 5 highways going into it. That's, again, not overwhelming. We can probably handle that. But as we zoom in a bit more, we'll see that, oh, wait a second, the 5 roads, we have 1, 2, 3, 4, 5. Those are just the interstates. Those are the main highways. But now we're already seeing there's a bunch of other little roads coming in. And as we go in even further, oh no, it's exploding more and more. There's far more things, far more different ways throughout the feature itself. I'm not even going from one feature to another anymore. I'm now in the feature itself, and there's just so many different things that can happen in a different order, so many different paths through the code. So, problem one with automation and testing in general is that there are, no, sorry, let me back up. Problem one with automation is that there are more kinds of problems than automation can be programmed to recognize. So what do I mean by that? Well, when the automation is written, it often will check for what I'll call summary results. So if you're doing a checkout, an online purchase, and somebody enters their credit card and all of their cart information and their shipping information, and they make it through all the way to the end, and they say submit. And at the next page, the last page, it says, "Thank you for your order, John." Okay. The fact that it says thank you for your order is what we're checking. So the automation sets up to say, after I click submit, I'll wait to a maximum amount of time, 10 seconds, maybe 15. And by then I should see thank you for your order. If I see those words, then I'll say that the system is in good shape and the test passed. The problem with that is maybe the text is a white text on a white background, or a light gray text on a white background that's really hard to see. Or maybe it's in a tiny font, or maybe it's in Wingding's font. It'd be unlikely, but there are a lot of things that automation will say this passed, when in reality, if a human was looking at it, they would say, well, that's not really good. And look, it says, thank you, Mr. John, instead of just thank you, John, things like that. But we're only looking for it to say thank you for your order. And then there's also the times that you get sometimes at companies, developers say, oh, I really shouldn't say thank you for your order. I should just say thank you, because there's times that it might not be an order. It might just be something. We're going to change the words. And so now the automation starts failing. So anyway, it's going to only be looking for what it's programmed to look for. And there are some things that are really, really, really hard for automation to be able to find. Things like the visual accuracy or the correctness of a page. Having a human looking at that is quite important. There's more checks to automate that can possibly be written. We've already looked at the map as the metaphor, and having so many different paths that can be taken, trying to automate all of them doesn't make sense. Some of them are actually equivalent to each other. If I execute going from north to south on First Avenue or 23rd Avenue versus 26th Avenue, I can still get from Downing Street over York Street. That's not a big deal. That'll work. But there's other paths that aren't going to work. Sometimes the roads don't make it there. And trying to automate every single path doesn't make sense. But it also doesn't eliminate the fact that some of those roads still may have issues. Problem number 3, some things are just too difficult to automate effectively. That was one I alluded to, the visual correctness of a page. Accessibility, some aspects of accessibility can be automated, like is the contrast between the foreground and the background good? You can automate that. But is the tab order correct? Does it make sense? Is the reader reading things that make sense in an order that makes sense? Is it being read clearly? Those are things that you cannot automate because the automation doesn't understand what it's doing. It's only executing steps. And so the step you could put in oh, this line here should be automated or should be read next, and you can check that the reader's reading that line, but you're essentially writing code then, and your code is checking someone else's code that's pretty much the same thing. So it gets difficult. Now, there are some times you can come up with a really clever way to automate something that does lend value to it. But for the most part, in almost every program, there's going to be things that are really difficult to automate and things as a consequence that should not be automated. So problem 4, let's assume that we're overcome the previous problems. We don't care that there's too many paths. We're going to automate all of them because our product's fairly new. So we're going to automate every path we can imagine through the code. We're also going to write automation for the stuff that's really hard to automate. And we're going to then execute our automation, and it has failures. And now we need to go and look at those failures and investigate them. And automation can be written in a way that investigation is easier, but it still needs to be investigated. It still needs to have a human go in and say, okay, well, when I tried to recreate this, it was obvious that the code had changed in the way that was intended. So the automation needs to be updated. So it was a false failure. There's also going to be times where the code actually picked up a real bug, and the latest release of the code has a bug that needs to be fixed so that the automation can run green again, and it catches it. That's obviously the ideal scenario and why we run the automation, so we can catch some mistakes. But the more automation you have, the more paths you have, the more likely it is you're going to run maintenance issues and taking a long time to investigate the failures. To write that much automation, or to write any automation, is fairly expensive, and it's expensive to maintain. No modern computer program is going to remain static over the entire life of the product. It's going to evolve. Thank you for your order, John, becomes thank you, John. That involves somebody going in and changing the automation in addition to changing the code to maintain it. Not everybody is going to remember to go in and update the automation. And so then when they check in their code, they'll see the failures, and you'll need to go at that point and update the code. You're also having to pay somebody to write the automation initially and to execute it until it's green, making sure that it's checking as much as it can, everything you want it to. But that's also a fairly expensive problem to be trying to solve. So, well, what can we do about it? Those are the 5 big problems that I came up with for some companies who are trying to automate too much. I worked at a company once where the senior vice president, he was in charge of the entire business division of a telecommunications company, and he sent out an email to everybody underneath him, everybody, saying one of the things in the email is that our goal is 100% automation. And when I saw him next, which was a few weeks after we sent the email, I was in our head office, which was in a different country, and I went into his office and I asked him why he had sent that email, because people were starting to try to automate everything, even the things that didn't make sense. And he said, well, that's not my intention. My intention was to automate everything that makes sense. I said, but those aren't the words you used. You said our goal is 100% automation. So when it's explained to the higher ups, the people making the decisions, the people saying, let's automate everything, when it's explained to them that it's not a good idea, often they'll listen and be able to act. So a better solution to many places I've been, I'm not saying a lot of places are doing this. I'm not saying where you work does this. But I've seen a lot of companies trying to automate far too much information at the GUI level, the graphical user interface level, instead of automating down at a unit test level or an API level. So developers can create unit tests that run much, much faster than UI and are often more reliable because they're not dependent so much on as many things working, don't have as many timing issues, don't have as much interaction, network problems. Many of those things are diminished when executing at the unit test level versus the UI level. You want to try to get as much business logic testing done at the API or unit test level. So by that, it's things like, oh, if it's an insurance company, when the policy switch from this type of policy to another policy, when does the price of the policy go up? How much does it go up by? What are some of the factors that are going to be causing the person to be rejected for insurance or have a much higher rate? How do they calculate the rate? Those types of things, if they are going to be automated, need or should be automated at the unit test or API level, not at the GUI level. And that is strictly for speed and maintainability and the ease of the automation tends to be easier at the lower level and far more reliable. Typically, the higher up the automation goes to a user interface or graphical user interface level, it becomes more brittle, more fragile, a lot more susceptible to failures. So if you are doing your business logic testing at an API or unit test level, and you as the tester are not involved in writing that automation, you should still be collaborating with the developers to look at the automation they're writing to see if they're covering the types of things that you would want them to cover. Plus, if you're aware as to what is being covered by their automation, then you can focus your automation that you're writing at the higher level to be testing different things. I have a follow-on slide on Minireviews, which we'll talk about in a few minutes. And at the UI level, you want to be focusing on the connectivity between features and elements and not on business logic testing. Occasionally, you may need to do that if just based on how some systems are configured and set up and how the different pieces interact with each other. But for the most part, I would suggest that your UI or GUI level tests are focused on, does this unit or piece of software talk to that section of software? And is the communication route working, as opposed to trying to do all of your automation or business logic testing at that level. So at the end-to-end testing level, having a strategic mixed approach where you still have automation at the GUI level and you want to automate critical paths. So you don't want to automate all of them. You pick the paths that have the highest use. So the main highway between feature 1 and feature 2, if most people are doing this one thing, then you want to do that. That's what you want to automate. If I'm getting a automobile policy insurance quote, then most people are going to have one car, 2 drivers, living in an urban city, and you want to pick the most common, most frequently used thing to be automating. You also want to automate the ones that are the most critical for the business. So not all of your scenarios, but you take the ones that are the most critical and you can talk to your business representatives on that, the product owner or your subject matter experts who are going to be using the software, and say, what is the most important thing to you? Where have you seen a failure in the past that's cost the company a lot of money? What do you feel we should be looking at and making sure works? Letting them know that you want the number to be fairly small. If a failure is found in the field, a test escape, something that you feel you maybe should have caught, and it gets out and then a bug gets raised or it's discovered by your customers or by customer support, don't write a UI automation for that failure unless it is a critical path or a path with a high usage. If you're already executing the path and not checking the right thing, you can add a check. But I have worked at a few companies or consulted with some companies where they want every single test escape, every single thing found out in the field. They want to write automation so that it will never happen again, which is kind of like if you owned a zoo and you had you've just bought a zoo and all of the animals are in their cages and one type of animal escapes. So the lions escape through a faulty cage. So you go and you fix that cage, and then every single day or every single time anybody walks by, they check the lion cage for that fault that you fixed already. You've already fixed it. It's likely, unless you have a really bad content management system, it's really, really unlikely that that same bug is going to miraculously come back and manifest itself again. So why are you wasting your time checking it over and over again when you could be spending some of that time checking on the other animals' gates and cages that you haven't found the defects in, catch before the animal escapes, search the whole product and look for the bugs that you haven't found yet, instead of checking that the bugs you did find aren't coming back. Now, if you do have a problem at your company where bugs that are fixed come back, well, guess what? Then you need to fix that problem of your check-in. If your merges are getting stomping over previous fixes, that's not a testing problem. That's a software development lifecycle problem and a content management problem. You want to consider the cost of all the automation you're doing versus the benefits you're seeing. If it's difficult to create, it's going to be hard to maintain because it's in an area that churns a lot. If it's really hard to analyze the failure, those are areas and things to consider that maybe this isn't the best candidate for the type of automation I'm considering. Maybe I need to be considering a different type of automation for that solution. And finally, on the strategic mixed approach, is have actual human beings, people who can think creatively, who can think critically, who can understand the situation, who can represent at a surrogate level your users, internal and external, your the stakeholders. You can have people recognizing as they're going through things that don't feel right or things that take just that little bit too long that it starts to be annoying. I was just about to click again to see if I'd clicked, if it had taken the click. That's just that little bit too long. And meanwhile, your automation would be gladly waiting until the timeout. So having humans supplementing the automation is a really good idea. And I also don't want anybody to think at this point that, hey, Paul Holland, he's against automation. I am not. We need good automation. We need a really good unit test framework. We need a good API level framework, and we need some UI level testing in the automation. And those should be part of the building pipeline and allow you to move more quickly. Automation is never going to find bugs that it misses the first time around. It's not going to say, oh, let's just execute it again, and it'll find the bug that it missed last time. It's not going to. It's always taking the same path through the code at the same timing. And I guess occasionally there may be a network glitch or the computer where the software is running has a few other things running, so it's running a little bit slower today, or one of the responses took that little bit longer and it does find a new bug. Okay, maybe, but that's not really going to happen a lot. While a human doing testing, not executing the same script over and over, but going and doing exploration, doing learning, questioning, thinking as they're doing their testing, that's the person who's going to be finding the new bugs. I like to think that the automation will find sort of the superfluous mistakes that the developers made. Oh, I didn't know that interacted with that in that way. That was my mistake. I should have known that. Automation is going to find that. Testing is going to find the bugs, the deep bugs, the interaction bugs. So automation limitations, they take the same path through the code each time. If it misses a bug once, it's going to miss it every time. It doesn't search for bugs. It's not looking for bugs. It's just going through the same steps and checking the same things. So if you're looking for clues, let's say there's been a robbery in a house and you as the detective are going in to find clues as to who did the robbery or what was taken or things that are out of place. If you were following a script and you enter the lobby and you turn left and you walk into the living room and you move the cushion on the couch and you look behind the cushion and then you go and look behind the curtains and then you go into the kitchen and you pull the door of the oven open and you look in there and then you pull the door to the fridge open and you move the milk and you put the milk back and you close the door and then you move on. And the very next day or even an hour later, you walk into the same house and you turn left and you move the cushion on the couch and you put it back and you look behind the curtains and you go into the kitchen, you look in the oven, you look in the fridge behind the milk, and then you leave. How many clues are you going to find after that first time going and looking in those areas? Every other time you go through, you're not likely going to find clues unless somebody comes along and drops a clue in that path. Or you change what you're looking for. You add a new parameter. Hey, when I'm looking behind the cushion, I found out that I need to check that there's no red behind the cushion. So now I start looking for red, even though I didn't know I was looking for that the first time. So you can modify your things you're looking for. But for the most part, if you're a human and you're entering a room and you're following the exact same steps, or you're testing your software and you're following the same script over and over and over again, or relying exclusively on automation, you are not going to be finding the bugs that you should be finding. Automation is typically performing limited checks. I already talked about this. Thank you, Dave. And it's difficult for it to check things that are visual. So I did say earlier that I wanted to talk a little bit about Minireviews. So a customer that I've been working for very recently has one of the teams had this, and it was, I thought, a great idea. So every single sprint, they have a meeting at the end of the sprint just internally with their team. And this customer, it's not their customer, they were my customer. So this customer held a 1 to 2 hour long meeting every single sprint. And each developer went through every story that they'd written and walked through every unit test. They spent about 15 minutes per story to do both of the things. And they would walk through the story. Here's the code I wrote. And it wasn't a code review time, but they did show what they had written, as sort of like a reveal. And then they showed every single unit test that they'd written and showed what they were checking for and showed that it was working. Now, why did I think this was such a great idea? Well, it allowed the entire team to provide feedback, identify gaps, learning from each other, sharing good ideas, and having a similar level of unit test coverage across all of the developers. So you now have, if let's say there's a new developer on the team and they don't really know too well how to write their unit tests, well, they're going to see how other people are writing their unit tests and be able to copy those concepts and those ideas. Plus, when they write their unit tests and show them, they're going to get coached and guided from the other team members. Plus, if there's any testers or BAs acting as testers on the team, they will be able to suggest, hey, you're not really testing this business logic rule, or did you consider testing this, or what happens if this happens, do the normal question asking aspect of being a tester. And I also thought that this could be expanded, that if you had a SDET or somebody writing higher level automation on the team, that they could be included and walk through what their automation is testing, so that the testers are aware as to what the lower level testing is happening by the unit tests, and the devs and everybody else is aware as to what the API or whatever level the crossover is GUI level tests are being executed. And that is the presentation. I hope you enjoyed it, and I will be able to answer questions as you send them to me. Thank you very much.